Hello. So I just thought I'd put together a quick video here to show the process of digitising a drone survey inside Virtual Surveyor to arrive at a cut fill balance. So we've got this sports pitch here down in Truro, and we just want to work out the remaining cut fill balance based on the latest drone survey. And then there's a little bit of extra work to do to sort of optimise the cut fill based on a new design change to push this battle forward. So I just thought I'd do a little video just to show you what that process looks like. So I've got a blank Virtual Surveyor project here ready to go. I've literally just opened this up now. And the first thing to do is go to New and then give it a project name. So I'm going to call it today's date. Truro sports pitch or update. And then what we're going to do is browse to the location where we want to save this project. So if it's a one-off sort of project, it can be stored locally on your files. If it's a project that everyone wants access to, probably store it in the engineering Dropbox. If it's ideally Virtual Surveyor gets used as like a timeline progression type software. So if it's going to be the same site repeatedly flown week after week after week, you'd want to store it probably in the engineering Dropbox, somewhere that it can be accessed by everybody and we can easily find the files that are associated with it over time. So at the high level, not buried in a folder somewhere, because you'll never be able to find it and it'd be a pain really. So I'm going to put this one, because it's a bit of a one-off, this one, we're just doing a bit of a final update survey just to do some cut fill optimization. I'm going to store this one in the same folder where the drone data is. So you can click in here and then create new folder, and it just creates this new folder here, and give it a name, whatever you want to call it. And we're going to store that project in there. When we're happy, so you can see the path to the folder, and that's the project name. I try and keep these names as short as possible really, because Windows starts to run out of file names if you're not careful. So create that project. And that creates a blank project with the template already loaded in it. So if you don't have this template, just get in touch with me. I'll make sure we get it set up on your project easily enough. So first things first for Virtual Surveyor, bit of housekeeping. The first thing to do is always to create a terrain state. So Virtual Surveyor works with these terrain states. So I find the best thing to do is label it by date, and the date of when the drone survey was actually conducted. So, and then click it to make it active. So nothing's happened in a minute, it's just a blank terrain state ready for us to import some data. Everything you do in Virtual Surveyor gets put onto a layer, no matter what the operation. So you'll notice the template's numbered, slightly out of sequence on this one for some reason. But step one is always import UAV data. So we're going to import the raw Ortho image and DSM mosaic. So the two files that Virtual Surveyor needs to work is the Ortho mosaic image itself, and this is the sort of standard Pix4D folder structure. So if we dial into here under DSM and Ortho step 3, we've got a mosaic and we've got a DSM, the digital surface model, which is this large TIFF here. So the two things we want to do, drag in the terrain information, the elevation information, which will take a couple of seconds to import. And then we also want to drag in the mosaic, which is that one there. So depending on the drone that captured these or the flight resolution, it might take a couple of minutes for these to import or not. It very much varies. You can import a raw point cloud. So this point cloud here can be imported and then converted into a terrain state. So if you don't have the DSM processed, or the elevation TIFF process, you can just use the point cloud, or if you've been given a third-party point cloud, it can work with that data too. But you will have to run a bit of analysis on it, so you can run a low-pass filter, a high-pass filter, or like an average of the two. And so both of these files have now been processed and they're ready to insert. So all we have to do is click on insert. That's the elevation TIFF with all of the elevation data, and then this one is the color information. Basically, is the ortho photo, but it just drapes the ortho photo over the top of the elevation TIFF, and they end up with a full 3D model of the site. So by default, it'll put these onto no layer. Layering in Virtual Surveyor is quite important to try and keep track of where things are, because otherwise it becomes a bit of a pain. So you can highlight these two and then drag them down to raw data, DSM and Ortho. The beauty of this is it can be turned on and off quickly. This data resides on this terrain state, which is where we want it to be. So if we were to fly the site next week or the week after, we create a new terrain state and we import the data, go through that whole process again, but on a different terrain state. And then we can flip between different dates and see the site's progression. So what I'm going to show you first is just running a volume in Virtual Surveyor. And then I'll also show you how to export data out of Virtual Surveyor to be used in TBC, because I need it in there to do the cut fill optimization. So step one, really, I want to just bring in, I want to bring in the boundary of the works just to make sure that this data fully captures the whole site, or just about. So you can bring DXFs, line work, surfaces, whatever, into Virtual Surveyor from other packages. So here we have the design model in Trimble Business Center. And the first thing I'd like to do really is to bring in the boundary of the work, as it were. So I tend to have this on a surface boundary layer. You see that kind of magenta line that runs around the whole of the design there, that sits on 6 surf 2D edge break line. I want to bring that into Virtual Surveyor just so I can kind of visualize where the design actually sits before I start bringing the surfaces in. Because we can do things in Virtual Surveyor like select within boundary, and you don't necessarily need to consider earthworks outside of that boundary. So I can quite simply just take that line, export it as a DXF. I think DWG works as well, but DXF tends to be more compatible with more things. So we're just going to export that as edge break line. P05, export. Right. And then we can either drag that DXF straight into here, or we can go choose files, and we can navigate to it through Windows Explorer as normal. So we'll go into modeling. We'll just grab that same DXF there. So it brings it straight in, pretty quick and easy really. As it was already on a layer in a CAD file, it will bring it in and create that layer within Virtual Surveyor. So it can be toggled on and off. You can leave it on that layer, there's nothing wrong with doing that. Or you can put it onto one of the preset layers in here. So I might move it up to volume boundaries, because this effectively will become my volume boundary after a while. So in the first instance, I can kind of see that this does cover everything that I need to, just about. And that I don't need to do any further analysis, but it's useful to have this boundary in here because I know that I don't need to digitize any of the earthworks beyond this point, potentially. That's entirely up to you. and I'll show you a couple of quick ways to do very quick digitization in a minute based on this boundary line. So you wouldn't necessarily even need to draw this out. If you have the design surface and you're happy with it, you can just bring this line in and get it to create a grid of points across it, and then export that into LSS, TBC, MForce, whatever. But the next step is I want the surface information for this project, for the design surface. So what I'm going to do is create a new terrain state. So these terrain states can be surveys, but they can also be design information. So I'm going to call this, well, let's call it the name of the project. If we go and export the surface first, actually. So this is the design surface. This is the finished level surface, but that's not my earthwork surface. So I want to export this finished design subgrade adjusted surface, which is the underside of earthworks with all of the surface depths applied. You know, offset for topsoil, the pitch depths, the stadium, the seating, whatever it's called, stand depth, etc. So in TBC, quite simply click this triangulation here, go to export. Virtual Surveyor works primarily with LandXML as a format, fairly industry recognized, quite compatible format. So if you're doing this from TBC, you can do this from LSS as well as a LandXML export, but I generally recommend triangles as a method. So this will only export the triangulation based on the fixed vertices points. If you click points and break lines, it will export the points and break lines that we use to create that surface. But if those lines don't exist, which they don't for the subgrade surface, the software that tries to recreate the surface from that information won't have a very good time of doing it. So generally speaking, I think triangles is quite a good way to go. So we'll call this FD subgrade adjusted. Chuck that there. We'll jump back into Virtual Surveyor and I'll create this terrain state, and it's going to be my design model name. So create that, and then if you click it, the screen goes blank because it's currently a blank terrain state with no data in it. So same process really. We're going to go to choose files, and then we're in the TBC export folder again here. We're going to click on that LandXML, open it up. And depending on how big these LandXMLs are, Virtual Surveyor sometimes takes a little bit of time to convert them all, but it does bring them in fairly quick. And then there's a little process we need to go to create a terrain surface from this triangulation. Because currently this is a tin, which is a triangular irregular network, and we're going to convert it to Virtual Surveyor's sort of native DSM profile. So again, that's brought it in on no layer because it just puts it on a default place. So it's all about housekeeping in Virtual Surveyor really. You can either drag it or you can do cut. And if we look in 7 surfaces, terrain models triangulation, there's a layer there ready for it. I think we've got to let it unload. So we're going to put that into there. So this software doesn't seem to be particularly well optimized for surfaces compared to some other softwares. It works with a slightly different format, but that's why there's a bit of a process to convert this from a triangulation into a terrain model. And the process of that is you can either tap it graphically in the 3D or 2D view, or you can tap it in this structure tree here. So if we tap it here, it highlights, or we tap it here, it highlights. You can change the visualization of this surface as well, because yellow is pretty horrible. We can make it grey, and we can also make it a bit thinner, which puts it into a kind of a normal sort of survey style compared to some of the packages you'll be used to. So the process with Virtual Surveyor is click the surface that you want to create a terrain state from, and then click Modify Terrain. And this goes through a bit of a process and creates this sort of terrain surface, which is very well optimized for running cut fill analysis to drone data. So once we have that, we can again put that into the same layer. The symbols here, this is the triangulation, the LandXML raw, and this is the terrain state data. So now we've created this surface, we don't actually need the triangulation anymore. You could actually delete it, I think. Leave it there just in case we need it again. So this is basically converting it into an elevation TIFF, same as the drone would produce for the survey anyway. And then once it is an elevation TIFF, we can compute volumes between the two very quickly. So I don't actually need to be in this terrain state anymore. So I can now jump back to this week's drone survey. So I'm just going up into the folder tree, clicking the new terrain state, waiting a second or two for it to load. Cool. So we're back in here now. So if we only care about a volume inside this boundary, and we just want an update survey on what's remaining, we can quite simply click this boundary and then do compute volume, and it will compute it to the design surface. Sometimes we want to do a bit of tidying up of the model. So there's a lot of this kind of rubbish in here that if we run the raw volume, we're obviously going to get a cut volume for the welfare unit here. We're going to get a cut volume for whatever that object is, for the cars, etc. So Virtual Surveyor makes it quite straightforward and easy for us to get rid of some of this rubbish. It is somewhat hard to see it in sort of the true color view. So Virtual Surveyor's got some quite interesting tools under analysis for visualizing things in different ways. So one of the things I find most useful is slope steepness. That just very quickly colors everything by slope, and you can very quickly see, you see every cone in there, every car, etc. You've also got tools for contour, so it will by default pick an interval, or you can type in an interval of, I don't know, 0.25 meters or whatever, and you can bring that up or down depending on what you want to do. Change the colors, etc., to make things stand out a little bit more. And you've also got bits for elevation. That's kind of for larger elevation ranges, but it's there, and slope direction, which is sometimes useful for batters and slopes, etc. I tend to find slope steepness works quite well for doing this initial step. So before we do any further volumes, there's an element of cleanup that we've got to do, and everything you do in Virtual Surveyor gets put onto a layer. So even removing this object, it will capture that action as an entity stored within a layer. So there's a layer here following the process through for object removal, cars, trees, etc. So I'm going to right click that one and set layer active. You can also go and select this layer up here from a sort of a standard CAD selection drop down. So I could come in here and select it here instead. If it's active, it will be highlighted white. So now anything I do in terms of data removal will get stored on this layer. So there's a quick AI driven function for removing objects, which works really well for discrete objects like this one, for example, this welfare unit. So what I have to do is click remove object, tap the object, and then Virtual Surveyor uses a little bit of wizardry and it will remove it nicely. Bits like this, it's going to struggle to understand where to stop this work. So there is this replace terrain function, which can be used either in the 2D or the 3D view. And what this does is, it's a bit like LSS voiding in the fact that you can kind of draw a polygon around an element, and it's going to grab the elevation from wherever you click, and it's going to void out the terrain in between. So you click, left click until you want to end the command, and then right click, and then it disappears. and you can see what's going on. It's triangulating from wherever I clicked across. So I might want to do that for the fence. Again, if it's a linear discrete thing like this, you might get away with remove object. But sometimes it does that sort of thing where it's done its best, but it's chopped out a bit of the earthworks there, which is not necessarily what we want. So if you do just go back on that one, Control Z, or back button up there. For things like that, you might want to get in there with replace terrain instead and sort of draw around the base of the fence. And you can get quite finicky with this, really. It depends on the level of accuracy you're going for. I don't have to draw around the whole thing either. I can strike through it. So I can strike through to there, strike through to there, 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 there. And this can all be done in a 3D view or the 2D view, or you can kind of switch between the two and get the desired result. So yeah, right click to end the command, and that does a much tidier job, and it doesn't destroy the bank. So that is generally the preferred approach for features that aren't discrete and clearly defined like that welfare unit was. I would say the 3D navigation and like general UI takes a tiny bit of getting used to, because it's slightly different to some CAD packages out there. But it's one of those muscle memory things that after a little while you just kind of get used to. And that flattens it. So the beautiful thing about having everything stored on a layer is that you can always go back and grab that information again. So if you decided that actually maybe I need some additional points in here for the terrain, you know, you can go back and retrieve that. So everything we do gets stored on a layer under these terrain modifiers. So they're currently active. If we uncheck them, then the fence comes back. If we uncheck that, and that fence comes back, and that welfare unit. But we can very quickly get rid of them all again. So that's kind of the beauty of it, really. And you say, what I normally do, I wouldn't bother removing anything that's outside of this white boundary, because there's very little value in doing that, unless you need that drone data. But yeah, it's basically now a case of just sort of zip through everything, get rid of the objects as best we can. So I think generally that covers most of the rubbish that's in the survey area. So before we do a volume, we just need to inspect the boundary just to see where it lands, because clearly the design, you know, the edge of batter goes a little bit into this hedge line here. And if we compute a volume based on this boundary currently, it's going to include all of this rubbish, which is not what we want. So I would probably at this point edit the boundary to come up to the edge of the earthworks, because we're unlikely to go into the tree line. The batter will end where the batter ends now, sort of thing. So what I'd probably do is in the 2D view, possibly just redefine this line. So if you click on a line in Virtual Surveyor, you can copy that line, or you can edit that line. You can do whatever you want with that line. So I'm going to copy that, and I'm going to paste it back onto this layer. So we'll call one true boundary VO5 design. And we'll call this one edited. So we can turn that one off now. With any of these objects, you can click on them and then go up to, I think it's tools, and then you can change the color of the boundary. So you can make it red, for example, or you could change the thickness of it. You could do whatever you want. There's a couple of different ways of doing this. So what I want to do now is just edit this boundary so it sits within the actual earthworks that I care about for the minute, because, you know, for example, this track, I'm not really interested in the volume of that at the minute because the trees are going to skew that volume considerably. So I just want to edit it to end it here, and same on the other side. So a couple of different options. One of the things we can do here is click on the line and then go to edit vertex. So this is quite a dense line, this one. So it might not be the right method depending on how many vertexes are on the line, but we can add our own in here. So we can split this line at that point and at that point. And then if we tap that, we can get rid of it. Tap and delete. So that's just edited it and removed that for the minute. And then if we're working on this layer, so I can set this layer active now, volume boundaries. I can come to home and create a new polyline, and it will snap to the end of that polyline. And snap to the end of that polyline. Snap to it there. Right click closes the command. So what I want to do here, click on that line again, go to tools, go to split that line there, and then delete that segment of it. If you click a line, you can go to merge polylines, and then they become one polyline, and it's labeled them there as one polyline. So that's a process. If you decide that, like there, for example, it's probably a little bit high up the bank, that polyline, so I can go to edit vertex, and I can kind of drag these now into any position that I want. And again, remember that slope steepness will considerably aid that process for you. And it will snap back to that point, I think. So same with this bit here. I'm going to go, I've already got that layer active. I'm going to go new polyline, and I'm going to look at it in slope steepness, just so I can get in there and grab the edge of the earthworks. So the reason I'm doing this is because I just don't, when I run the cut fill analysis between the design and this week's current drone survey, I don't want to compute any volume outside of this line, because obviously it's going to include that Harris panel and then eventually the tree line. So it's just about picking a sensible boundary. So we'll snap to that point there. Probably look at it in 2D. So at the minute we don't want that Belmath junction including. So again, tap the line, go to tools, go to split the line there, split the line there, exit on the keyboard, escapes out of the current command that you're in, and then you can tap that line and delete it, or you can save that line and relayer it to something different. But that's why I copied this, so that I've always got the original still toggleable if I need it to be. So just go around the whole thing really. Bits like that, a bit of an outlier I suppose, you might just want to consider whether that needs to be included or not. Probably not for the minute. So again, we'll do the same sort of process. It will, the software's quite clever in that it will snap anywhere along the line too. It will by default snap to near. So it'll either snap to a vertex or it will snap along the line, and it will create a vertex on that line then. But yeah, that's sometimes quite useful. It's the same process. We're going to trace around the edge of the earthworks. And there are tons of tools in here as well. It works really well for exposed earthworks, obviously, because you don't need to do any further analysis or adjustment. However, for areas where you have vegetation, what I've tended to do in the past is when I'm out there flying the drone, I'll walk through that area with the GPS rover and just grab a series of spot levels through the grass, and then I can sort of get an average depth of the grass or average height of the grass. And then with Virtual Surveyor, you can sort of draw a boundary around this grassed area and drop it by a certain amount before you digitise it further. So that's a quick way, if you've got vegetation in your survey, just to avoid it out, really, and to make a sensible assumption about the depth of that terrain. So again, split. Bit. Interesting. Don't worry about too much of the fact at the minute, because obviously this is the design target batter line, so that's why the 3D doesn't quite land on the model yet, but we'll fix that in a bit. It doesn't actually need to, it could be 2D for all we care. It's just a boundary, it's just a 2D boundary, really. That's fine. Fine. And everything I'm doing can be done in the 3D view or the 2D view. You just got to be aware of where you're clicking, because if you're not careful, you'll hit that red spot there, for example, and then it'll go halfway up the fence. So that's why I quite like working in the 3D view. If you're in a command, say, and you've put a load of vertexes on points, and you want to remove those points, if you tap backspace on the keyboard, they'll just sort of disappear. So you can go back. So if you make a mistake like that, you can go back to the beginning, and we'll start again. And that is sometimes quite useful. So I'm very quickly just going to run through here. You can, if you want to, instead of tracing around that, you can go across it like that, end that command for a minute, go back into, I don't really know what's happened there with that bit of tree. Maybe it was an overhang that the drone didn't resolve very well. If we set object removal active again, go to replace terrain, we'll go, the more points you tap, the more points it triangulates across. So we can just, try and redefine that batter somewhat. You could do that across this all as well, but it's going to make negligible difference for what we're doing here. So I'm going to reset my layer active there again, go to polyline, go back to the polyline that was working on, tap to the end of it, and then just carry on as I was then. Same thing. Oh, you'll notice, so when you click an object in Virtual Surveyor, it highlights, but then you also get this highlight tool at the top under selection and then tools. So these aren't visible unless an object is highlighted. So if I tap off that object, that disappears. Tap on the object, it reappears. So I want to split it there. And I want to split it there. and then I want to delete that object. So I'll just breeze through these next few little bits. Okay, I'm just going for exposed earthworks here. Like I say, we can snap to that line there, right click, escape, and then we should be able to snap to that point on the line because it creates a vertex on both points of the line. Like there, delete. And then same with this one. You can, like I say, if there's not too many vertices on the line already, you can go to edit and then you can just kind of drag these to wherever you want them. This will get quite tedious quite quickly because these triangles were set to every meter. So that's why I generally think, you know, sometimes it's best just to create a new line at the interval that you want it to be at. We're just going to intersect it there. And then back to tools, back to split, split. Tap it again, tap that one, split, delete. So for the most part, that defines what I need it to define. For bits like this, it's probably as quick just to do that. Let's drag them into where we want them to be. So now this line, instead of being my edge of design line, this is effectively my edge of exposed earthworks line. So it's my current survey boundary, or the boundary of usable data, basically. Anything outside of this boundary is somewhat unusable at the minute. We'd have to supplement it with rover data, or, you know, once the site clearance has progressed, we'd get in there and we'd survey it again. But what I want to do now is I want to join all these into one line, because at the minute it's many separate lines. So I can do it again, I can do it graphically by clicking point and then control click and going around and clicking everything, or I can hold down shift, select all of the objects within that selection set. And then underneath tools, we've got merge polylines, which will merge all of those into one line. If you click on the line, if it doesn't have a 2D area, if it doesn't display area in here, it's not closed. So you'll find here it isn't closed. And the best way of closing it is to click that object, if it's a short gap like that, and then click to boundary. And then you'll find it'll have a 2D area. Every operation in Virtual Surveyor normally starts with a closed boundary, same as Trimble Business Center. So it's best to have these sort of closed if possible. So that's good, that's working. And that's the volume boundary that we're going to use to compute the cut fill. So the beautiful thing about Virtual Surveyor is that I don't need to do anything else to this now. I have the raw pixel perfect elevation data here, and I can use all of this in my volume computations without having to downsample it to a ½ meter grid, or, you know, whatever we normally do. What I'll do first is, this line is currently at the elevation of the 3D design in TBC. So it resides at this level, which isn't necessarily the earthworks level, because you know, this would have targeted the original ground survey. So, but if I'm going to bring that data out, it's going to triangulate to that line. And we want that to be at the correct elevation for the drone survey. So if I tap on the line, again, under tools, we've got several options in here. We can densify it, although that line's already quite dense, so we probably don't want to do that anymore. But we can get that line to change its elevation to terrain. So when we tap that button, you'll see what happens. Let's go find a bit that's obviously stuck up in the air, like that bit was. So see, that's currently floating in air somewhat above the trench. if we tap to terrain, that's going to sample every vertices on that line and it's going to drape it onto the terrain surface, which will be useful later for reasons that I'll explain. So that's effectively the digitization of that for the moment. That's all I want to do. Now I'm just going to call that Earthworks. The more you label in here, the easier it is, really. So I can now run a volume between this drone survey and the design terrain state. I can also run cross sections between the two. So if I go to Profile, again, everything you do in Virtual Surveyor gets put onto a layer. So if I want to draw a cross section, I'd recommend putting it onto this cross sections layer so they can be turned on and off. But the nice thing about this tool is it's dynamic. So as you update the site over time, right click to end the command. It brings up a cross-sectional profile view of the site. At the minute, this is just the active survey, so the active earthwork survey. If I add a terrain state, I can add the design survey as a profile line into that. It'll compute a profile through there. And then all being well, everything will be quite close, really. So we can see the top pitch here, which has currently got 100mm surcharge on it. And then the bottom pitch should have about a 50mm surcharge on it. But generally speaking, the earthworks profile is looking very good, apart from the areas that are still to be filled. So it's all looking quite good, really. Don't worry too much about things like that. That's just a void in the terrain state surface. So the actual edge of triangulation is governed by that point. So in theory, there's no design there, although we'd just end up regrading it to the topsoil strip level. So it will just stay like that, really, and it won't compute a volume in there anyway because the boundary doesn't govern it. You can start to see the pond come into shape there as well. So profile view is quite useful. It'll show it all in the graphic or 3D view as well, the profile, and that's why I say it's useful to have it toggleable on and off. So now we want to compute a quick volume between the two surfaces, just to see what our work remaining is and to see what, in this case, what the deficit of material is going to be to complete the final design. So I'm going to store this volume on this number 5 volume computations layer. So I set that layer active. Everything in Virtual Surveyor starts with a boundary. So I tap that. If it has an area, it can be used for a volume computation. If it doesn't have an area, it can't be used for a volume computation. So you've got to go and figure out where your open lines are and close those out. So if we go to tools here, we've got tools for volumes and cut and fill analysis. So under volumes here, the reference type is going to be, we can run it against the 3D triangulation, but as the triangulations get bigger and bigger and bigger, this becomes more of a problem. But this is quite a useful tool if you've got stockpiles that you want to compute a special floor of. You can get in there and start editing the levels. I'm just going to run it against the terrain state. And I'm going to pick this terrain state here. And then all I need to do is click cut fill. Depending on the size of the survey, it'll take a couple of minutes to do that or not. But this is working with the raw drone data, not downsampled. It's as accurate as it could possibly be. So we get a nice heat map here, showing the cut and fill. And we can change the colours in here to whatever we want to do. So we can also do cut fill analysis here. and we can change the spacing of that cut fill map in here. We can look at that in the 2D or the 3D view. So anywhere in blue is still to fill, anywhere in red is still to cut. And you can confirm that in the cross-section view as well. So in the cross-section view, wherever your cursor goes on the cross-section here, you can also see that strike line through there. So here we've still got fill to go. You can see the two elevation differences there. And you can also see that profile line. So the blue is the subgrade model and the black is the current drone survey for that week. So we can turn that off. If we go to volumes computations and click on it, we've got here the cut and fill balance quickly displayed. So at the minute, it's telling us we still need to fill 7,800 cube, and we've only got 2,700 cube of cut still to do. So there is a bit of a deficit. You can quickly copy that to your clipboard and paste it into an email and send it off to whoever you want to send it off to. Or you've got tools to export that within Virtual Surveyor as a report function. You can also toggle the volume on here. And there's options to change all of this. You know, you could put work remaining. Whatever you put in here gets displayed in the 2D graphical view. You can also change the resolution of this cut fill map. So that's a 50mm resolution at the minute. So this is quite useful for messy drone data or for comparing this week's survey with last week's survey to make sure that the drone data is accurate. So you can set sort of a standard GPS tolerance of 30mm, you know, and compare one drone survey to another. Or if we know that our earthworks tolerance is 50mm, we can set it to 50mm. Anywhere that's red or blue is outside of that 50mm tolerance and may need further work depending on, you know, if surcharges are being used, etc. So that's effectively it on the volume inside Virtual Surveyor side of things. But that just gives you a quick idea of how quick that can be achieved. You know, once you get into the swing of it, it can be very quick. So when you if you were to fly this again next week, you could come and create a new terrain state for next week. You could copy this same boundary because there's probably no point in redoing this work. All we need to do is copy that. Copy, go to the new terrain state, paste it into the new terrain state, and then you might need to edit the odd vertex just depending on if the site's progressed in any way, shape or form. As it stands at the minute, what I want to do with this data is bring this surface into Trimble Business Center for further analysis, because I need to do a bit of design refinement now to generate the extra material required to meet this shortfall. So effectively what we're going to do is we're going to have to drop this pitch here by some amount, retarget these batters to try and generate the extra material required to fill this blue section over here. Plus we've got a little bit on the pond left to cut there still. But I'm going to quickly show you what the digitization process looks like now and how to get this data out of Virtual Surveyor and into Trimble Business Center. So I can turn my cut fill map off. I already have my earthworks outline boundary that is draped onto the current terrain profile. There are lots of tools within Virtual Surveyor for digitizing this. If you're going for extra points or you're doing a digitization, you know, properly, I always treat it like I'm surveying with a GPS rover. So you'd want to add break lines in to the top of banks and bottom of the banks. So there are layers, standard layers in here for top of bank, bottom of bank. So I can come into here. Again, useful to have slope steepness turned on. And I can start to digitize my top of bank. So this is an alternative approach to the sort of indiscriminate, let's just grid it at 0.5 meter approach. And it certainly looks a lot nicer if you're sort of putting deliverable drawings together for a client. And if it's going into a product like LSS, it will certainly appreciate the lower resolution, digitized surface rather than just a pure big point cloud. So there are tools. That's just me tracing it manually. There's also this guided break line function. So if you tap on guided break line, I'm still in the add line command here. So I was currently in free edit mode there, but I can tap on guided break line instead. And if I just pick an approximate meter in front of me and pick the next point on the top of bank, the software is going to do quite a tidy job of grabbing that top of bank line, and it saved me quite a lot of digitization time. It's not perfect by any means, so it started to veer off the line a little bit there, which isn't ideal. So use it at your discretion. Sometimes it is easier just to come back in here and split it there, and we'll just delete that line and we'll go again from that point. And we might edit this point, edit that point there, and bring it back up like that, put it back onto the line. But you want to go through to find top of bank, bottom of bank, details like this, for example. You want to go through and just define that as steps and points, etc. And then once you've done that process, you may also want to grid levels across it. So if you're going through the process of digitizing properly, getting in top of bank, bottom of bank, as if you were doing a rover survey, you'd probably want to grid the site at sort of a 5 or 10 meter interval, which would be, if you were walking it, doing a walking survey would probably be all you'd do. If it's just a quick survey and you're not too worried about digitizing break lines, bottom of bank, top of bank, DTM, level line, etc., you can just indiscriminately grid 0.5 meter across it. So I'll quickly show you what that process looks like. Again, everything in Virtual Surveyor starts with a boundary. Just tap the boundary. What I want to do here is I'm going to put my spot levels onto this spot level layer. So I'm going to right click and make that active. Just as a reminder, that can be done in here. So it's now, anything I do is going to be put onto this layer. Tap this line, and then under the home button here, I've got point grids. So I'm going to go for 0.5 meters, which should be quite intense. There are options in here for low pass. So if you've got a particularly vegetated, like sporadic vegetation, this will go through that area and pick the lowest points in there and put a point there. So it will deliberately avoid hedges, tops of trees, etc. Rectangular and triangular, just going to indiscriminately just grid levels across it, no matter what's in the way. So that's why it's very important to ahead of time remove any of the erroneous data from the data set, because otherwise it will hit the top of this, and that's not what you want. And Q points is an interesting one. It uses an algorithm to try and best represent the terrain. I'm not 100% sure it produces the nicest looking data in the world. So, but it is interesting. And certainly if you're just going for a small file size, just for a quick survey, it would be more than sufficient. So click on point grid. That's going to go through the survey now and sample that and generate you a point every 0.5 meter on a rectangular grid. It's going to drape that onto the terrain surface. It isn't the fastest algorithm in Virtual Surveyor, to be honest. It's not the best, but it does get there. And then it's fine after that point. I like to tap on these and go and change the visualization because yellow is just awful. So I tend to make them white, and I tend to make the shapes a rotated cross, and I tend to make it quite small. I just think it looks a bit better. But that's just creating me an indiscriminate half-meter level grid. And if I tap on it, it highlights every point in that grid. I can also tap Z and it will give me the elevation on each one of those points, which is sometimes useful. Yeah, lots of options. So you could at this point let me turn off the slope steepness. I'll turn off that for a second. So you could at this point export this line and these points as a DXF and bring that straight into LSS or Trimble Business Center or whatever it is you want to bring it into. Alternatively, you can create a tin triangulation in here and export that as a LandXML and bring that straight into any of the other packages. If you're just interested in the elevation data, if it's a proper topo survey, you'd probably want to do the line work as well. So once you digitize top and bottom of bank everywhere, you bring that out and you put spot levels on it, etc. It's worth saying you can have multiple grids in here. So that's my grid 0.5 meters. Nothing stopping you from turning that off. Is say that that's too dense. Say I can go to home. If you've got break lines in there, that's the key here, because otherwise it's going to miss a load of critical detail. I can do a 5 meter level grid instead, which is obviously going to be a lot quicker. But the consequence of that is obviously it's going to triangulate from there to that point, and it's going to miss out the crest of the bank there. Hence why you need a break line in there to define the DTM creation. But this will create a much nicer, cleaner topographical survey that can be plotted on drawings, etc. So lots of options there. So I'm going to create a triangulation directly inside Virtual Surveyor using this data that I've digitized. So I'm going to set my DTM triangles layer active. And then from the graphical view, I'm going to select this line and this line. And then I'm also going to select my point grid, my half meter level point grid. So those are highlighted now, all of those elements. And then I can go to tools. No, I don't. I can go to triangulate all under home. It'll take a second or two and it will create me a triangulation. But we've got that age-old problem that most DTM software suffer from, where they can't quite understand that we don't want a triangle across this void space. So in LSS, you'd come in here at this point and you'd use void surface code and just delete out this surface code. In mForce, you'd strike through and delete these triangles. Same in TBC, you'd just strike through and delete them. I'm just going to clean this up and turn these off for the minute. So that's my dense triangulation now. But what I can do, I can use this line as a boundary for that DTM. So if I highlight that line, you might have to zoom in and just highlight the line like that. Like that. So I'm going to highlight the line, I'm going to highlight the surface together. And then if I go to tools, and then if I go to clip outside, what that's going to do is it's going to trim the DTM to that line. Right, so that has now trimmed the DTM to that line, which is what we want. So look at that in the 3D view. We'll turn our point grid off. We now have a nice clean triangulation with none of the trees in there, no fences, no vehicles, just a nice clean terrain surface that we can use for further analysis. So what we can do now is we can tap that DTM either again from 3D graphical view or from the project tree here. Tap it, go to export, go to XML, go to export survey, and then we will, we can stick it wherever. I'd recommend sticking it in the folder we created for the Virtual Surveyor project, and then copying it out from there. So everyone, if you're digitizing a discrete survey, everyone will then have access to that LandXML data should they need it for something. So we'll call it 500mm levels DTM. Save, and it'll export that out quite quickly. So once we've done that, we can then bring that LandXML into any other survey package that we want to do further analysis in. So if we look at that in a 3D view, I'm going to change the color of that to something like brown, and then could give that a name, UAV update. UAV update survey. And then when we strike a section through, we've got the same data that we had in Virtual Surveyor, but it is now a nice, clean, downsampled, tidied version, which shows us our earthworks profile and outline. And we can run the same volumes that we would run in Virtual Surveyor, but in TBC. But I now have this surface to conduct further analysis with. It's my nice, clean earthworks profile. So there is no erroneous data left in there. It's just nice, clean data, ready to go to the next step. And we can see that where I digitize that break line, we've got a nice crisp line for the top of bank. Where I didn't digitize that break line, we've got this sort of detail going on because of the 0.5 meter interval that we chose as the sample. So that's just sort of a difference really between the two methods. You'd get, if you did a 5 meter level grid and a top of bank line here, you'd have a really nice clean survey. But again, it's just a case of the time and the task at hand. But yeah, any questions, just drop me a message and I'm happy to go through it.